The idea is that you have some sort of source. It's called usually the single source of truth, which is usually a database. In the case of web caching, is the remote server. That is the authoritative source of truth, and you get the information from there.
Hey everyone, and welcome back to the Modern.NET Show, the premier .NET podcast focusing entirely on the knowledge, tools, and frameworks that all .NET developers should have in their toolbox. I am your host, Jamie Taylor, bringing you conversations with the brightest minds in the .NET ecosystem. Today we're joined by Jody Donetti to talk about FusionCache, caching in general, and what in-memory, distributed, and hybrid caching are. Please note that hybrid caching isn't the same as the Microsoft library HybridCache, although HybridCache does implement hybrid caching. Confusing, right?
That's the first problem. The second problem is that by using a distributed cache directly, you pay the price of network calls and deserialization every single cache call that you make.
Along the way, we talked about open source development, how Jody got started with working in the open, and that listeners should never be scared of working in the open. If you're building something for fun or just to learn rather than to give back or create the next big open source library, then let people know in the documentation or the README. Before we jump in, a quick reminder. If the Modern.NET Show has become part of your learning journey, then please consider supporting us through Patreon or Buy Me a Coffee. Every contribution helps us to continue bringing you these in-depth conversations with industry experts. You'll find all the links in the show notes. So let's sit back, open up a terminal, type in .NET New Podcast, and we'll dive into the core of modern.NET. So Jody, welcome to the show. It is an absolute pleasure to talk with you today. We've crossed paths a few times, I think, at things like MVP Summit.
Yeah.
But I don't think I've ever actually had the stop and chat with you yet. So this is really my first proper interaction with you. But welcome to the show. It's a real pleasure to have you.
Nice to be here. Thank you very much for inviting me. I'm for everyone not knowing me, which is basically most of the people that will listen to this. I'm Jody Donetti. I'm a principal engineer, and I've been doing coding, R&D, architecture, stuff like that for a good part of 30 years right now. So yeah, a bit. And one aspect that I kind of specialized in along the years is caching. And so some time ago, I released in 2020, actually, at the very end of 2020, I released FusionCache, my very first open source project, which is a hybrid caching library with some pretty advanced features, mostly about resiliency and performance improvements. So yeah, that's me.
Cool. So we're going to talk a little bit about caching and things like that, and especially about FusionCache in a moment. But I also know, before I even say congratulations on this, you have a course out at the moment with, I believe it's Dome Train. And I wonder, could you talk folks through that and why they should take the course, I guess?
Good question. Yeah, so some time ago, Nick proposed me this course. At first, I was honestly like, I don't know, a course, really? People should listen to me mumbling about caching stuff. But then it clicked in a way, and I decided to pour all of myself into it. So basically, this is the first course, and there will be a second one out hopefully soon. I'm working on it like day and night, but it's a lot of work. And it's getting started and deep dive on caching in .NET. And the idea is to cover for the ground up from the very beginning what caching is, what caching means, the pros and the cons, which is important to know, the various best practices, but more than that, all the building blocks, the little concepts that you can then use in your day-to-day projects, work, or your open source project, or whatever that is, to get it in a better place. Because with caching, there are a lot of advantages that you can take out of it by using it. But you also need to know where not to use it and how not to use it. So I try to cover them all, to cover all of these in the course. In the Getting Started course, I'll start again from the very beginning. You don't have to know anything except for a couple of things about C#, how it works. But apart from that, nothing. And even though it's called Getting Started, I already go a bit advanced in it. But I try to do it both in the Getting Started and in the deep dive that I'm working on right now in a very approachable way, hopefully, if I've done my job well, so that anyone can jump into it and learn something new about caching. I don't cover, by the way, only FusionCache, which of course I'll do, but also caching in general and other caching libraries like the new HybridCache in .NET, which came out with .NET 9, and an overview of others in the open source community, which honestly, it's an amazing place. I think the .NET open source community is full of rich projects that everybody should know. I think not just about caching, but anything. And so, yeah, it's out. The Getting Started course, the first one, has been out for a bit over a month right now. And I have to say it's going well. Some people completed it, and I already received some reviews, which were honestly good. So I'm happy about it. And some people even took some time to leave comments. So explaining what they liked, what sometimes maybe not. And overall, I'm very happy about it. Yeah.
Cool. And folks can get hold of that by going to the Dome Train website, can't they? I know I'm going to have a link in the show notes, so you're probably best for. I won't get a kickback from it, but you're probably best, folks, to use the link in the show notes because that has a reference code so that we can track it back to Jody sharing it with folks. So use the link in the show notes. But I guess if people Google for getting started with caching in .NET, it'll come up, right?
Yeah. Yeah.
And how long's the course? Is it like a couple of hours or?
No, there are a lot of things I wanted to cover. So at first, the idea was to do a course, like singular, and then I started putting out, the structure of the course, which chapters and lessons and this and that, and it immediately became obvious that it was too much stuff that I wanted to cover. But I want this to be the one-stop place to get familiar with it and then get really proficient with even pretty advanced topics like distributed caching, multi-level caching, notifications and stuff like that. So I wanted to cover it all. And to do that, it became pretty long. So I had to split it up into two, getting started and deep dive. Now, the getting started courses in general are about 4, 5, maybe 6 hours. Mine is 7 hours and 15 minutes, something like that. The second one, I don't know because I'm still working on it as we talk. And yeah, I don't know, probably a bit longer. But again, the idea is that if you take these courses from beginning to end, you've been able to see everything you need to know about caching in general, but in particular in .NET, because of course some concepts will be very general. You can use it even in other languages or whatever. But in particular in .NET, we'll see libraries, including mine, but not only that, patterns that you can use, things related to how the language works in relation to how do you use a cache library. So I would like to cover it all, and that takes time. Yeah.
I mean, that makes sense, right? Like you said, there's a lot to learn. But also, that means that folks who pay for it are getting a lot of value for money, right?
Yeah.
Because there's a whole bunch of knowledge in there to know.
Yeah, that's the whole idea. I wanted people to feel the value in what they bought, both if they bought the course as is, like only the course with like lifetime access, which is something that can be done in the first. Right now, the thing is the first 72 hours when the course launch, people can buy it and have it forever. And then there's the like all you can eat buffet, like the Netflix style. You pay a monthly subscription or I don't know, 3 months subscription, something like that. And then you can watch any course on the platform, which is actually pretty great for the value that you get back. But anyway, yeah, that's the point. And the way I try to structure it is to be again approachable. I don't want people to have like a problem getting to understand a new concept or a technique or a specific option, a feature, something like that. And so I want this to be very, very approachable and that people can come back to later when, they may look, at least that's what happened to me sometimes with some videos online. I watched the video the first time to basically get introduced to a concept. Then time went by, maybe I've not used it, and then I start needing it, and so I get back to it later to make myself clearer on the subject. So that's the whole thing, in my opinion. Having a place where you can go back to even later and rewatch some lessons, some chapters to make it click, if you will.
That's really cool. Because like one of the things I don't really like about book learning is that I feel like sometimes I'm locked to specifically what's on the page. Now, obviously, in a video course, you're locked to what's on the video course, but I feel like it's much easier in a video format to have those links between previous lessons and next lessons. Hey, we're going to talk about this soon, but when you get to that lesson, come back here and remind yourself, all right? So I'm currently reading through Richter's CLR via C Sharp just to get a better understanding of how like the CLR works in intermediary language.
Mhm.
And I would say I'm about an eighth of the way through. It's an 800-page book and I'm 100 and something pages in. And I'm like, this doesn't make sense yet, but I'm hoping it will soon. And I feel like that tends to happen more with book learning than it does with videos, right? Usually I find that with videos, maybe because the video creator can almost see all of the content,
Mm.
that you can jump backwards and forwards and go, oh, cool, we covered that in that first section. So I can tell the person to go back there and I can maybe just include it again, right? It's a little easier, I think, to edit video content than it is to edit a book, because otherwise loads of people will be book editors. And it's way easier, I suppose, to see that content when you are editing through a video course. And then you can provide like the supplemental content, like here's a cheat sheet or whatever, right? You can't easily do that in a book.
Yeah, but you touched on an important, you touched on a very important part, which is taking away a lot of time. Actually, at least for me, I'm a newbie related to educational material creation, but I'm taking this hopefully seriously. Meaning, I really try to play it and see how it will feel from the eyes of the people watching it in the future. And what I mean by that is it's not just taking everything and dropping it on a screen with some videos, because that is like all the information will be there, but they will not be digestible, they will be understandable. Okay, so the a lot of the time I spent creating the first course and now the second one is not just like writing down the things that I want to talk about, but also restructuring the information in a way that is again digestible. So, for example, you spend a lot of times writing on resiliency, but then I think, wait a second, but I'm mentioning these and this and that, and I've not yet covered those things. So it's better to cover them before, so that it makes more sense as you watch it through, as you go through it. But then those are different connections. So it's a lot of work in reorganizing the information and creating like a storytelling in a way that makes sense. And the more you go on, the more you have something new that you've learned. So it keeps being interesting and let's say nice to watch, but also you get to learn something new that the next day you can go to the office or whatever and use it right away. That's something I strive for. I don't know if I've been able to do it. Let's hope.
Well, I have every confidence in you, Jody. Having seen some of your talks, like the NDC one that you did recently, I have every confidence in you that you have put something together that fits along a curriculum style lesson plan. So, yeah, I absolutely fully appreciate that you will have done that. So, full confidence.
Yeah, in general, I can say that if you already took a look at the FusionCache documentation, which the community seems to particularly enjoy, that's like an expanded version of that, meaning I will go broader and more deeper into every possible aspect of caching from a 360-degree point of view with the same style. So hopefully, again, approachable and with illustrations and drawings. So it takes a lot of time to do that too, but yeah, that's the way I do it. So yeah.
Cool. Okay. Well, folks know they've got to go check this out. Yeah, they should definitely check it out because otherwise they're not going to learn about caching. But we're going to cover a little bit of it today. So I guess if we're going to talk about caching, I know that there are lots of different ways to cache something and lots of different ways that you might think of caching something. For the web devs out there who've done a lot of front end work, my vision of how caching works is my web page loads and my browser says, hey, server, can I have this static content, CSS, JavaScript, image, something like that? And then the browser will hold on to a copy of that file, either as long as the server tells it nothing has changed, or maybe I can somehow detect if I'm the browser. If nothing has changed, I'll just serve that version of it. And this comes from like back in the day when we were on 56K modems or whatever. It
Yeah.
took a lot of time to download images and CSS and JavaScript, right? And so if we can keep the file, if it's not going to change, we may as well keep it and just reuse it. And then the page will load faster in bunny quotes. It doesn't really load faster, but it feels like it loads faster, right? So that's one version of caching that I know we can sort of fall back on as an example of what caching is. But you're talking specifically about server-side caching, right? Which is different to front-end caching.
Yeah, it's different, but conceptually, caching is what you just described, meaning it's a way to use a little bit more resources in terms of, for example, memory, which in the browser is either disk space, because then it's stored on disk or in memory, in exchange for CPU time. So basically, it's faster, to say it bluntly. So that's the whole thing. And then the real complex part is okay, how to be sure that when something changes, the cache is notified of that. It's like, so there are different techniques, different pros and cons in each approach. You have a balance to find. I will say that in most for most things in life, the secret is always to find the right balance, not go too extreme in one side of the or the other. And so this is the same. The same is true for caching. So, for example, how long should you cache something if you don't know when it will change in the future? Because nobody can predict the future. This is one of the main topics of caching, and I'll go through it in the course. But apart from that, the idea is that you have some sort of source. It's called usually the single source of truth, which is usually a database. In the case of web caching, is the remote server. That is the authoritative source of truth, and you get the information from there. And then instead of going to the source every single time, which takes time and resources and can be also brittle in case of transit issues, what you do is you use your own local copy. This is very briefly caching in a nutshell. The thing I did with FusionCache is try to avoid people going through the pain that I've been through along the years. I have to say decades right now, actually, with an easy to use solution where I try to put the learnings that I got through the years into well documented, well modeled, hopefully, and uniform to use features and options and stuff like that. So basically, I can go through any one of the features or the options that I created in FusionCache, and I can tell you why for where that came from. Oh, that one time when we had issues with production, and it was like what you can think of Black Friday or whatever. We need to squeeze, I don't know, 1 month of sales into 4 hours or whatever, and there was an issue with caching. And how did we do? How did we survive that? Well, it was messy, it was bad, it was a lot of effort and stressful. And then I came up with, what if I can do something to make something like this easier for the next guy, which can be very well me the next time it happened, but also somebody else. And that is how basically FusionCache was born, and that was is trying to do.
So that's, I don't know if it translates well, but obviously British and American English, we say that necessity is the mother of invention, right?
Yeah.
You've had, it sounds like a lot of time in your career where you've maybe thought, gee, I wish this would be easier to do with a cache. And then you've gone, wait, why don't I just make that happen, right? Be the change I want to see, and then give it away for people to use, right?
Yeah, exactly, exactly. And I have to say, shout out to the what was the back then the Stack Overflow, the dynamic duo, meaning Nick Kraver and Mark Gravel. They were colleagues at back in the time at Stack Overflow, and one of them, I think, was Nick, posted a blog post which was titled "How We Do Up Caching at Stack Overflow," like 2019 edition or something like that. Up until then, I never had a single open source project. I never created one. I contributed a bit here and there, patches, those small bug fixes, stuff like that. But I never felt like I was in the right place to like say my thing in a way. But I wanted to contribute back more. And when they posted that blog post, it was for me like a validation, if you will, of some of the ideas around caching that I had for a long time. I already used those ideas, those patterns, those best practices, those techniques. But one thing is you use it for yourself, they work and you're fine, and that's already pretty good. But another thing is trying to put it out for others to use. You don't want maybe to distribute the wrong idea to maybe it's your own thing that works in your own way but not in other situations, and you don't want people to maybe be poisoned by that if that is not actually the right call. So in that moment I remember reading their blog post and I was like, oh, so that was not so much a stupid idea after all. And so that was like felt like a validation in a way. And I was like, you know what? Okay, let's just put my face on it, and in a way, because in reality, I hit my face away. But anyway, like let's took the plunge, as so to speak, and I will get out with my very first open source project, and that's how it was born. And then a long time, people ask me about new features, and then others I come up with them with real life experiences or something like that. But yeah, that is how it was born and how it went along in the last 5 years already, almost 5 years. Yeah.
That to me, I always enjoy listening to people's origin stories, both in tech, but also in open source, right? Because in both of those instances, there is something that I can learn as an open source maintainer, admittedly of something rather small, but as an open source maintainer, I can think, wait, I never thought to actually sit there and think, just because I use it, does it need to be open source? Those weren't your words, but like, am I distributing the wrong answer to a
Mm,
problem, right? Because that just ends up with developer confusion, right? Because if I say, here's this package, and I'm going to talk specifically about me here. I'm not saying you've done this, Jody, but if I'm distributing an open source package of some code and say, this solves my problem, and leave the sentence sort of hanging there, then someone who reads that might think, well, if it solves Jamie's problem, it obviously will solve my problem too, right? And so then that person will then attempt to use that or may attempt to use that open source project just because it's open source and just because someone has said this has solved their problem. But that might not actually solve the actual problem they're seeing. I like that. I hadn't really thought about that. Does this solve the actual problem? Is this a good solution that everyone can use? That is something I've never really thought about. So I really appreciate you bringing that up.
yeah. Even though I like not to maybe give the wrong impression, meaning for people listening, don't take this as a sort of a blocking. Like if you are thinking about releasing some open source project, do it. I mean, if it has a minimum of reasonable shape or it makes some sense, publish it and maybe put a warning like, "Hey, I use this in production or on a project, or whatever. It worked for me. No strings attached, but be careful. Maybe I'll add some documentation later to explain how it works. But it's not wrong to don't feel like your code does not have value or something like that. Because honestly, I released it thinking, probably in 2 years time frame, nobody will have downloaded a copy. Maybe I will have, I don't know, 100 downloads or something like that. Maybe it's stupid. There are already other amazing, honestly, caching libraries out there. So in a way, I felt like, who am I to get another one? Like, why people should get this one instead of another? But of course, it will not go this way every single time. But to me, it has been an awesome experience, not just releasing it and finally deciding to go out with that, but also what came after. And not just in terms of, I mean, I've been lucky enough to get both a Google Open Source Award the first 6 months, and the next year a Microsoft MVP award. So that was great, and I'm really thankful for that. But take that aside, that is cool. But the community that is being built around it a bit with time with some time, like people commenting, "Hey, I've used that in my project and it solved an issue." That to me is the best thing, because when I know that somebody used my thing and solved an issue that they had, that's like, okay, I helped someone. It was worth. That's it. So I would suggest people to try that because it's really a good feeling.
Yeah, no, I agree. And I know that that's me backpedaling against what I was saying, or it may sound like I'm backpedaling and taking my point back, but it's not. It's two sides of a different coin. Like, folks should always feel free to put something out there as open source. And as you say, right, put like a disclaimer that says, this is me just trying something out.
Yeah,
If you want to use it in production, here be dragons, right? You're on your own. I make no disclaimer that this will actually work, but yeah, putting stuff out there and just trying and almost like learning in the open is super important. It's how I have boosted a whole bunch of my skills just by like going, I wonder how this works. I could learn privately, but if I throw it up on a stream, on a live stream, or I throw it into an open source library and then ask some friends who I really trust, like, does this make sense? Am I doing this right? How else are you going to get that code in front of them, right?
yeah. Absolutely, absolutely. Yeah, the one thing I will say maybe is just be humble, because as cool as you may think you are, and you may be, not you, Jimmy, of course, in general, people listening, there's somebody out there who is definitely better than you at some parts of what you did, and that they may help, and you can get better, and then in turn you may help somebody else later. It's a circle. It will go for a full circle. For example, about this first circle thing, I've been inspired by, I've been like, I felt like validated by the blog post by Nick River and Mark Gravel, like a second flow. Jump in time 2024, they both were working at Microsoft, and Gravel started working on HybridCache, which is the multi-level caching from Microsoft that came out with .NET 9. And we then had a discussion, or multiple discussions, where we basically shared some ideas, or at least I tried to suggest some ideas, some things that I've been through with caching in general and with FusionCache as a project. So things like the shape of some methods, or maybe it's better to introduce this now than later because otherwise it will be a breaking chain. Small things like that. And the cool thing, and again, shout out in particular to Mark Ravel, which was the team lead with HybridCache, is that they listened. And the cool thing that came out was that they not only created their own multi-level cache thing, but also they came up with an abstraction, meaning HybridCache from Microsoft is not just their own implementation, there's there too, it's a separate package, but it's an abstraction. It's like iDistributed cache, which is the shared abstraction for distributed caches, but in this case, HybridCache is for multi-level caches. And that means that people like me in the community can create we can create our own third-party implementation, which is what I did actually. So on top of having this collaboration with the Mark and the team, sharing of ideas and stuff like that, in the end, I created a small adapter for FusionCache to be used as HybridCache, the Microsoft abstraction, which is a nice moment of going for full circle, if you will.
Yeah, that's really cool. So they kind of inspired you to put out FusionCache originally, and then Mark Gravel worked on HybridCache, which inspired you. You let's just say it, right? I'm going to say it directly. He was inspired by your work to
I don't
put
know.
together
I don't know about that.
HybridCache.
I know there are.
I bet he was. I bet he
I don't know.
was.
I don't know. Honestly, there are some common points, yes, but I don't know if I inspired him or not. For sure, he has been really really nice in giving me some of his time to talk about that. I thought that that could have been a good move for the open source .NET open source community when they announced it, if done right. And I think that they done the main parts right. Meaning, for example, again, the fact that it's an abstraction and not just their own thing that people cannot, do anything about it. That was really, really good move. And I think probably that came from Mark's past as an open source maintainer. Because just for people that don't know him, I don't know if somebody in the .NET space don't know him, but we're talking about protobufnet, we're talking about Dapper, Stack Exchange, Redis. I mean, in the open source .NET space, he is like the guy. So yeah, the fact that he spent some of his time chatting about this new HybridCache thing and how it could have played out alongside FusionCache instead of against, that was really, really cool, and I appreciate that a lot.
And then, like you said, full circle, right? So that you were able to contribute back towards FusionCache to allow it to be used alongside how that's yeah. I love open source innovation.
Mm-hmm. Yeah.
Admittedly, if it weren't for closed source, most of us would not get paid. But I love open source innovation, being able to go, hey, that's really cool. Let me see if I can make something like that, or make my thing work with your thing, because your thing is open and I can see how it works, and my thing is open and I can see how it works. So let's get this to work together, right? That collaboration, it's amazing.
Yeah. And also, to touch upon more on that, you talked about my thinking work with your thing. In the case of a multi-level cache, like it is FusionCache and HybridCache, the so-called second level, which is the distributed level, is not just one thing. It can be Redis, it can be Memcache, it can be Garnet, it can be this and that. And to talk with a with a distributed cache, the distributed level, the second level, you need to serialize stuff. So you need to talk with a serializer. And so again, you need to be able to talk with protobuf, you need to talk with JSON or XML or what it was that message pack, memory pack. There's a lot of different projects that needs to be able to communicate with each other, or at least that FusionCache, in my case, needed to be able to communicate with. In the case of FusionCache, you can pick the serialization format and the serializer that you want. So you can plug it in, the distributed cache based on Redis, for example, as the second level, and the serialization format with the protobuf serializer, for example. And all these pieces need to be able to, communicate in some way and find the right balance to make everything work out. That is really great.
It really is. It really is. Today's episode of the Modern.net Show is brought to you by RJJ Software, strategic technology consulting for ambitious SMEs. You know me as the host of this podcast, but here's what you might not know. I'm also a Microsoft MVP who's helped businesses from Formula One teams to funded startups to transform technology from a cost center to a competitive advantage. At RJJ Software, we specialize in 3 things that matter to growing businesses. AI that actually delivers return on investment, not hype, just practical implementations that pay for themselves. Developer experience optimization. We've helped teams to achieve 99% faster deployments and 3x productivity gains. And strategic technology decisions, from architecture reviews to fractional CTO services. The difference? We don't just advise. We ensure successful implementation through knowledge transfer to your team. If you're an SME leader wondering why your technology investments aren't delivering, or if you're facing critical decisions about AI, modernization, or team productivity, let's talk. Visit rjj-software.co.uk/podcast to book a strategic consultation. Now let's get back to today's episode. We have stepped a little bit away from how caching works in FusionCache. I love this conversation, but I'm just thinking that, people who are listening in who don't know much about server-side caching have heard you say multiple things like hybrid caching, multi-level caching, level 2 caching, things like that. I'm just worried that someone's going to be listening going, they're talking about stuff and they haven't explained it.
Yeah, absolutely. So if you will, I can give like the 2 minutes intro to that. So basically, caching on the server side means because of the caching that we talked about before, like in the browser, but for data in the server side. So imagine your C# web server, website or API or whatever. When you actually now, without caching, go and talk to a database to grab the data, there at that point you can introduce cache. And what it does is you go to the cache, basically you ask the cache, hey, do you have this data that I otherwise had to go to the database to have? And if the cache says no, it can go and grab it from the database and then store it in the cache for subsequent faster access. This is the very short version. Now, this is caching in general. Then there's the issue of, okay, what type of cache should I use? Memory, distributed, I heard these terms, but I don't know exactly what that means. Long story short, a memory cache, you can think of it like a dictionary in .NET, for example, because basically it's like a piece of memory where you put data, and each piece of data is identified by a key, the so-called cache key, which is, again, like a dictionary. You have key value and that's it. This is cool because it's super fast. When you try to access a piece of data in memory, it's a memory access away. So there's no network call, there's no nothing. So it's super, super fast. And this is why it is also, and there's no dependencies, meaning you don't need to spin up a database, Redis or whatever. It's just a dictionary memory. This is cool until your application restarts for various reasons, maybe crash, maybe you deploy the new version or whatever. When the application restarts, you have a problem called cold start, meaning you start and the cache is empty because, again, it was like a dictionary memory. And this is the first issue. The second issue is that it's called horizontal scalability, meaning, okay, you can deploy your website or API or whatever on one node. But what happens when you are successful, hopefully for your project, and you need to deploy on multiple instances? That can be multiple instances on one node, multiple single instance on multiple nodes, multiple pods. Today we are in a containerized world, so Docker, pods, whatever. In those cases, each application will have its own memory cache, basically any memory dictionary. So each of them will need to go to the database to grab the data and then save it locally, and then can create issues. So the solution to that usually is, oh, okay, I will now switch to what is called a distributed cache. A typical example is Redis. Redis is a remote service. So by storing the data remotely, it allows the Redis to survive application restarts because the data is out of process, it's remote. And not only that, but data can be shared between different nodes because, again, you can think of a distributed cache like a database. It's a database. And this is, by the way in which I very quickly explain things in the course, is you can think of a distributed cache as a database. And the next question is, okay, so I have data in my database and now I need to put the data in another database. What's the point? The point is that by nature, by design, distributed caches are simpler in features and in what they guarantee, mostly around ACID compliancy or, for example, around persistence. Some of them, like for example, Redis, by default is remote, but it stores data in memory. It's super fast, but if you restart it, all data is lost. If you use it as a database, that can be an issue, and you can cover that by enabling the persistence part. Otherwise, it's just a memory. But if you use it as a distributed cache, you don't care because by nature, a cache is temporary. So by using a distributed cache, what you get to survive cold starts. So when the application restarts, and then horizontal scaling, because multiple nodes can talk to the distributed cache and grab the data from there instead of having to go to the database each of the nodes. And when you have something like the other day, a guy in the community explained to me his setup, and he has like 20, 25 around different applications deployed in pods, like Kubernetes pods. And in total, he has something like 400 pods. Now, if you have 400 pods and you have 400 memory caches, 400 pods needs to go to the database, and the database load will increase, and then you pay more on your cloud bill or whatever. That's the whole idea of going distributed. The problem now is, and I close this off, the problem now is that first, you started with the memory cache, so you created your code against that piece of code, and now you have to switch to a distributed cache. So you need to go around and change all your code to work with a distributed cache instead of a memory cache. That's the first problem. The second problem is that by using a distributed cache directly, you pay the price of network calls and deserialization every single cache call that you make, because the data, since it's remote, is basically a byte array, it's binary. So you need to grab it from there by doing network call, and then you get back a binary, and then you deserialize it. So it is more costly than a memory cache. Still less costly than a database. Again, it's all a game of balance, but more costly than memory cache. So here is when a hybrid cache or a multi-level cache came into the picture. The idea is you code against one unified abstraction that can be either one level or multiple levels. In the case of hybrid caches, there are typically two, L1 in memory and L2 distributed. The hybrid cache takes care of the internal communication between the two levels, so between the memory cache and the distributed cache, which is the second level, such that you get the best of both worlds, memory and distributed. How? The first access is always in the memory level. So if the data is cached there, it's super fast. You do not allocate a single byte. It's super, super fast. If it's not there, the hybrid cache will say, okay, let me check the distributed level, which is shared between different nodes. And so maybe another node already populated it with the data that I need. If it's there, it will take the data from there, put it down, deserialize it, and put into the memory cache, because the next access will be from memory, super fast. It will do all of these for you. And not just that, but by being able to enable and disable whenever you want the distributed level, the second level, the cool thing is that you can start immediately using a hybrid cache, configure it with just the memory level, basically as if it's a memory cache. And only later, when you need to scale out, you can enable with one line of code during setup the distributed level. And all of your code that is using a hybrid cache will not need to change. This in not 2 minutes, but maybe 4 minutes. It's the short version of why it makes sense to go hybrid and use something like FusionCache, HybridCache, or something like that.
Okay, so let's see if I understand then. So we've had on the show in the past Jerry Nixon, who talked about data application builder, which
Yeah.
we know already uses FusionCache, which is awesome. But he had said that it doesn't matter it doesn't matter how you build your app, the slowest bit is always going to be the database, right?
Mhm.
And so, first off, talking to the database, you have to go over the wire, right? Whether that is over to a remote server or a server on your machine, it is still having to travel out of your app to get some data to bring it back, right? So that's always going to be slow. Whether it be slower to read from disk, I'm not sure. I don't think I've done the maths there. I think it is still slower to read from disk, but doesn't matter. So you've got your database. That takes a while to get that data back. So in order to make that more efficient, if I can cache those values somewhere closer to my app and maybe in memory, maybe as this distributed cache, that means I'm not having to hit the database as much, which means I can get the information faster, which is awesome. I fully understand that. And then there is a hybrid model where I can have my cached data stored in memory, which is great. That's super fast. But then if my app dies or I need to push a new version or maybe the pod that it's running on falls over or whatever, I lose that data. So I want to maybe push some of that data out to the distributed cache, which is where the hybrid idea comes from, right? I can say to the hybrid cache, FusionCache's hybrid caching and say, I need this to be stored somewhere. I need it to be accessible, but also the app may restart. So you figure it out, right? And so then that way, I'm not having to make that trip all the way back to the database to come back. And like I said, it maybe that the database is on your machine, but it's still a long distance to travel, right? We're still moving electrons, right? So it still has to physically travel somewhere
Yeah.
to come back.
Yeah.
And then you were saying about how the different levels of caching is just like level 1 is our local in-memory cache.
Yes.
Level 2 is our distributed cache. So my question, I guess, so is distributed cache, is it called a distributed cache just because it's not on my machine? Or is it a distributed cache because I can then maybe create copies of that? Like I can horizontally scale my app. Can I horizontally scale my cache? Is that something that happens?
So, okay, that's a nice question. So, in general, you have to think about a distributed cache as one thing, just like you can think of a database as one thing, even though the specific deployment of one specific database that you have may have, master replica or primary, secondary, or whatever. That's an implementation detail of the infrastructure that you picked. Maybe maybe your infra guy, or whatever.
Mhm.
In the case of the supercache, the idea is that each instance of your application running, multiple servers, multiple pods, whatever, will have its own memory cache, which is again like a dictionary in memory. Whereas the distributed cache is one for everybody. Again, it's like a database. So everybody connects to the same distributed cache.
Okay.
If then this, let's say it's Redis because it's one of the most common. If this Redis is one server or it's 5 servers in a cluster or whatever, that's a different problem that is solved in a different way. Logically speaking, it's one. So that's the key part. So you have 1,000 nodes or 1,000 pods. 1,000 pods will all connect to the same Redis instance as a second level. But what I call the dance between the first level and the second level is all taken care of for you by the HybridCache, by FusionCache in this case or another.
Okay. So I have two questions, and I know you know these two questions are coming up.
Uh-huh.
Just because they are likely questions you get all the time.
Okay, let me see if I know the first one.
So we did a lot of conversation so far about you've used Redis as an example because everybody knows it. So first question, super common question, I guess, is so is Fusion Cache just like Redis? If I know Redis, do I know Fusion Cache?
Yeah, I knew that will come up. Yeah, so it's not a matter of one versus the other. There's not such a thing because Redis, it is used most frequently, let's say, as a distributed cache. FusionCache is not a replacement for that. You can use whatever distributed cache you want with FusionCache. So you have Redis, you can just use Redis as the second level, the distributed level. Any distributed cache can be used as a second level with FusionCache. Oh, you're using Memcache instead of Redis, same thing. You can use Memcache as the second level, the distributed level. So it's not a matter of one versus the other. Okay. Of course, you can use Redis directly. Of course, that's a given, and not use FusionCache. But this is the scenario that I talked about before. If you use a distributed cache, you will always go there. And as you mentioned, probably said by Jerry Nixon, a distributed cache, just like a database, is remote, and that will always be slower than accessing something in memory, which is the first level, the memory level. So this is the thing. You can use Redis as the second level.
Okay, so that was my first question. Is it just Redis? No, it can be used with Redis. It can be used whatever you want.
Mm-hmm.
So the second question is, okay, so let's say I have, and again, this feels like it's a question you'll get a lot. I have 1,000 pods. You've just said that, right?
Mm-hmm.
We've got 1,000 pods. We've got 1,000 replicated versions of my app. All 1,000 go down at the same time. All 1,000 come back up at the same time, and they need to refill that in-memory cache. So all 1,000 of those apps, and hopefully you can see where this is going, all go to the database because we've got 1,000 users, for instance. Each user has hit one of those individual pods and sent the same request. I want the same thing. I'm sending to the same API endpoint. I'm going to receive the same data.
Yeah.
All 1,000 of those users will hit one or more of those pods, which will have no in-memory cache. So then all 1,000 of those requests for the same thing will go to the database and come back. So what happens there? Is that like literally 1,000 times, like I need to go to the database 1,000 times to get that one thing to then eventually cache it afterwards once everyone has it? How does that work?
Yeah. I thought you would come to that. So in general, so first, short answer, no. If you're using a hybrid cache, like a FusionCache, for example, which has two levels, and you configure it with two levels, so memory and distributed, the situation you just described means that all of those thousands pods will need to go on the second level, not on the database, on the second level. So in our case, for example, a Redis instance, which is already way better in terms of performance and load for the database than going to the database. So they will go to the Redis instance. But the real question, probably the real thing you're talking about, is cache stampede. Did I get it right?
Yep.
Yeah. Okay. So the very quick way to think about it without anything visual to see is this: leave aside thousands of pods or whatever. You have just one good old web server, pretty old, like 20 years ago, whatever. Now, 1,000 requests come in to the web server for the same URL, for the same piece of data at the same time. And the data that they need to fulfill the requests is not yet in the cache. Without any special care, what will happen is that all of those 1,000 requests will check the cache, see that nothing is there, call the database, do the query, so 1,000 queries to the database at the same time for the same data, then get back the result, save it into the cache, and then return the data back. Now, of course, the next requests will be served by the cache. Cool. But that first time, it's called cache miss. So a check in the cache when the data is not there, that will trigger 1,000 different database queries. And this is bad. This is known as cache stampede. Now, how can you solve it? It's very easy, but it depends on the library you're using. For example, let me put it this way. If you do a get call to get the data from the cache, then check if it's null or not, something like that. Usually it's if null or something like that. And in that case, you go to the database and then you separately do another call to save the data in the cache. There's nothing that can be done, meaning the cache cannot help you in preventing this problem, this cache stampede issue. If, on the other hand, you call a method that is usually called, it depends on the library, but it's usually called get or create, get or set, get or add, something like that. Again, naming is hard and every library uses different names, but that's basically it. If you do that and you provide this method, basically the cache key that you want to get and a factory is called a factory, but basically it's like a piece of code, a lambda in .NET, which is the logic that can go to the database or whatever that is, a remote source, and grab the data. You give that to the cache and you say, do your thing. In that case, the cache can help you. And if the cache supports cache stampede protection, which FusionCache, for example, and even HybridCache by Microsoft, they both do, what they will do is they will coordinate the different calls to the cache and to the database such that only one query to the database will be executed. This is called cache stampede protection or prevention or something like that. And some caching libraries provide this feature and some don't. Now, one common mistake is that when people start to learn about this is, I know if the caching library has a method called getter set, getter create, getter whatever, it means then that it protects me from cache stampede. This is not true. So much so that, for example, one of the most used caches at all in .NET, which is memory cache, the one out of the box in .NET, does not protect you from cache stampede. So in the example I made before, 1,000 requests for the same piece of data at the same time, you will get 1,000 database queries, which is a big of a waste. Could be prevented if instead you switch to HybridCache by Microsoft or FusionCache by me, even just configure it only with the first level, so you don't need to specify a Redis instance, set up something. It's basically just a normal memory cache in a way, but it's a higher level cache, which gives you automatically cache stampede protection for free. You just change the method call and that's it. And you can forget about this problem forever.
I really like that.
I don't know if I answered your question.
Yeah, no, that's a great answer to the question. I like not having to worry about something ever again.
Yeah.
So I guess the lesson here is go read the documentation for the library you're using, folks, and make sure that you're calling the methods in the way that they are meant to be called.
Exactly. And check if it supports, in this case, cache stampede or something like that.
You know that moment when a technical concept finally clicks? That's what we're all about here at the Modern.NET Show. We can stay independent thanks to listeners like you. If you've learned something valuable from the show, please consider joining our Patreon or buy me a coffee. You'll find links in the show notes. We're a listener-supported and, at times, ad-supported production, so every bit of support that you can give makes a difference. Thank you.
By the way, since you mentioned documentation, I care a lot about documentation. So the docs of FusionCache, I spend a lot of time in, drawing illustration to clearly explain things and, explain, putting down the text and then rewriting it to make it more approachable. So if you are interested in these concepts, even leave aside FusionCache for a moment. Who cares? You will not use it. Okay, fine. If you go to the FusionCache documentation, I hope that you will find some of these things explained in an easy way. For example, the page about cache stampede, I work on it a lot and I evolved it a long time to make it very, very approachable. So illustrations and stuff like that. So the idea is you can learn something from it, even if you will not use FusionCache, you use something else. It's good. And just quick note here, we talked about just FusionCache and HybridCache by Microsoft and by me. There are other really good caching libraries out there in the .NET space, in the .NET open source space. And I would like to just name a couple because if people is interested in this, I suggest them to also take a look at these other libraries. Cache Tower, Cache Manager, and Easy Caching. These three, plus HybridCache from Microsoft and FusionCache for me, I think these are the 5 main caching libraries, multi-level, let's say, caching libraries in .NET that people should take a look at because they're all interesting in some ways.
And it's always worth knowing about the alternatives, right? Just because you've always used this particular library or this particular technology is not always the best reason to just continue to use it, right? Having a look around and seeing how other people are doing things is always a great positive thing to do. So I fully appreciate the shout out to the other caching libraries. And definitely, folks, if you're interested in putting some caching into your app, you need to know what your options are, right? So go check those out.
Yeah, I also put a comparison page in the FusionCache documentation just to know, which features are there or not in this and that other library and stuff like that. So that may be also something interesting to look at.
Amazing. And I have to say that if the images in the documentation are anything like some of the images you've used in the NDC talk that I referenced earlier on, everyone will be able to follow those. I guarantee it, because those images are brilliant.
Thank you. Yeah, that's basically my style in a way. It's also a way for me to decompress from coding. So you code, and then okay, performance tuning, and then oh, come on, documentation, and then, oh, okay, enough. I'll draw something. I'll draw an illustration. These are all I'm drawn, and then I scan them and tweak them. But yeah, it's a way for me to decompress a bit.
Ah, nice. So there's lots of talk about caching today, lots of talk about open source, lots of talk about caching. We have covered a little bit about what FusionCache is, how it works, how it relates to HybridCache and Redis and distributed versus in memory, and why you might want to put that kind of thing in place. So before we sort of sign off, because I realize we're running low on time, if folks want to learn about FusionCache, I know you mentioned the FusionCache documentation applies to not just FusionCache, but has some sort of generic caching advice and learnings in there as well. So are they just hanging off of the GitHub page for FusionCache, or is there like a different website that you have to go to get to that documentation?
No, it's just that. It's just that. And in the main README file, I link to the main topics there. And I use that because it's all work to work on the documentation, and I didn't want to maintain a separate file. And honestly, the target is developers, so the GitHub repo is more than enough. So between the illustration and the layout, I hope it's as accessible as possible, even though it's just a bunch of markdown files on a GitHub repo.
Amazing. Okay. And obviously I'll have a link to the GitHub repo in the show notes. So hey folks, just give that a click, a press, whatever action it is you do to navigate to that page. Go check that out. What about if folks are listening in and going, this is great, I want to learn more about all of this stuff? Can they connect with you on socials and things like that? I know that some people don't have, literally, I've met some people in technology who don't have socials because they just don't have the time for it. So like, are you contactable?
Yeah, absolutely. All my DMs are basically open. You can find me on LinkedIn and Twitter, Blue Sky, GitHub, wherever there's a way to send a message. They are usually open, unless I'm in a bit of a moment where spam is a bit too much. But as of today, not yet. So
Okay.
yeah, contact me freely, and also if you're interested in, even before maybe going to grab the course, if you are interested, there are some videos, some videos that I made where they invite me, like you have been kind enough to do today, and in the FusionCache repo, there's a link on a separate repo with the talks that I've made, so including the NDC one that you mentioned before, and others. So yeah, you can start from there, all free, and then if you want to go deeper, maybe you can consider the course, but otherwise it's fine. Otherwise, of course.
Awesome. Okay. And then just to remind folks about the course, that's on Dome Train, right?
Yeah.
And that's getting started with, well, okay, at the moment, on the day that we are recording, Tuesday, 11th of November, which, yes, folks, we're recording this instead of watching .NET Conf. That's the course that you have out at the moment is getting started caching with .NET, and that they may be a second part by the time folks are listening, perhaps.
Yeah.
I'm not trying to pressure you into releasing it for then.
No. There will definitely be. I don't know the exact date when this will come out, but I hope it will. I will finish working on it soon. Let's say a month-ish, something like that. It's really a lot of work, so I cannot guarantee a date. But yeah, if this goes out published after the end of the year, definitely. Otherwise, Nick will kill me. So Nick Chaps, that's the from Downtrend. Yeah. The first one is already out. The second one will be out very, very soon.
Amazing. Okay. Coming soon. Watch this space. Awesome. Well, Jody, I really appreciate you coming on the show today to talk about caching. Obviously, I did cheat, folks. I have watched Jody's talk at NDC and read some of the documentation, so I know some of the words to use. But yeah, no, I have had an amazing time chatting with you, and I'm walking away from this knowing way more about caching in general, not just FusionCache, but also I have more thoughts and conversation around open source, which I think is really good. That conversation we had about open source, where just do it in the open anyway, and just tell people it's experimental. It's not going to. It may not be for production. I'm just learning how to do. Please don't use this in production, or maybe you want people to use it in production. I don't know. But yeah, that idea is fantastic. Yeah, thank you for that.
And thank you very much for inviting me. I really, really appreciate it.
Hey, no, I appreciate having you on the show, Jody. Thank you very much. Thank you for listening to this episode of the Modern.net Show with me, Jamie Taylor. I'd like to thank this episode's guest for graciously sharing their time, expertise, and knowledge with us. Be sure to check out the show notes for a bunch of links to some of the stuff that we covered and a full transcription of the interview. The show notes, as always, can be found at the podcast's website, and there'll be a link directly to them in your podcatcher. And don't forget to spread the word. Leave a rating or review on your podcatcher of choice. Head over to .netcore.show/review for ways to do that. Reach out via our contact page at .netcore.show/contact, or join our Discord server at .netcore.show/discord, all of which are linked in the show notes. But above all, I hope you have a fantastic rest of your day, and I hope that I'll see you again next time for some more .NET goodness. I'll see you again real soon. See you later, folks.